Right, this one is inequalities and number lines. Right, inequalities and number lines. What should we do with this one? Well, first of all, we'll do the number lines. Now, a number line is like this. It's just a line full of numbers. Yeah, and we'll divide this up. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, imagine that they're all the same. It would be, obviously, in a printed exam. And so we can have 6 and 7 at the end of the number line. It could be anything, yeah? And what they do is they go, here's one. What number should be on that point there? Now, what you need to do is find the difference between the first and the last number. So, yeah, 7 minus 6 equals 1. So there's the difference. And then find out how many divisions make that difference. There are 5. So it's one complete number divided by 5 and change it into a decimal, which is 0.2. And this means each division is 0.2. So you can go 6.2, 6.4, 6.6 and 6.8 and then 7. So your answer is 6.8. That's how to do a number line. If we have a number line with a different, let's do 1, 2, 3, 4, 5. So we have, say, let's go from 10 to 14. We've got 1, 2, 3, 4, 5 divisions. And the difference between the two numbers is 4. And the divisions are 5. So you change that into a decimal. So 4 divided by 5. So let's do this a long way. 5s into 4 don't go. 5s into 40 go 8. So each division is 0.8. So you've got 10.8. And another 8 onto there is 11.6, 12.4, 13.2 and 14. So, for example, that one would be 12.4. So that's how you find where the missing number is. Now, inequalities is the other part of this, and we use some symbols. Now, 3 equals 3. That's okay, that's pretty obvious, isn't it? But 3 does not equal 4. So there's another symbol that we might see later on. Now, the inequalities symbols are this one, which is more than. If you read it left to right, so 5 is more than 3. So it points down to the smaller end and opens up to the bigger number. Now, if we read it left to right to left, then it's less than, because 3 is less than 5. So this sign can be flipped. 4 is less than 7, yeah, or 7 is more than 4. So you can have it both ways, and you can read it left, right, right, left. Now, other symbols are this. There. Now this means more than or equal to. So x is more than or equal to 6. Therefore, possible values for x are, it could be 6 because it could be equal to 6, or 7, or 8, or 9, or 10, or 11, and so on and so forth forever. So there's an arrow at the end of there. Now we can flip this round. We can have x is less than or equal to 10. So possible values for x are 10, 9, 8, 7, 6, etc. So these are reversible. You can read them left to right, right to left, as the same with these. Now, we have another kind of number line here, and we're going to marry up the expressions to the number line. So let's have a look at a number line. So we're just going to do 0, 1, 2, 3, -1, -2, and -3. Now, you will be given an expression and asked to represent the expression on this number line. So the expression is x is greater than -1. Now, when you have a greater than sign, you put the -1 on here, and it's an open dot. And x has a value of everything beyond -1, so bigger than -1, so it goes like that. If you have x is less than 2, you put the open dot above the 2, and this time we go the other way, smaller. As long as you put the arrow on the end of the line, it doesn't matter how far the line stretches. So this is, again, is an open dot. Now, do it again with another line. 0, 1, 2, 3, -1, -2, -3. Now this time we use the other symbol, which is x is greater than or equal to 1. So we put the dot, which this time is a closed dot, and we put that above the number 1 there, and the closed dot just means we fill it in. Now x has a value everything bigger than or equal to 1, so it's that way. And we can have another one which is pointing the other way, which is x is less than or equal to 0, say. So you put the dot, a closed dot above, oh no, not there, but in the wrong place there. So you put the closed dot above the 0, and this time it's equal to or less than, so we go that way. So there's the 4 combinations, the 4 different symbols that we use and how we use them. Open dots for more than, less than, closed dots for more than, less than, or equal to. Now, we can have a combination of both. So this time, we're going to put our number line there, and 0, 1, 2, and 3, and -1, -2, -3. So we'll have x in the middle, which is greater than -2, but less than or equal to 3. So the -2 open dot is there, the +3 closed dot is there, and we simply join them up. And the possible values, this might be the extra bit, yeah, possible values of x are going to be more than -2, so it could be -1, 0, 1, 2, and include 3, because it could be equal to 3, possible values of x. So let's do another one on this and swap the signs around. So x is greater than or equal to -1 and less than 2. So -1 is where we put the closed dot, and 2 is where we put the open dot, join the 2, and the possible values of x in this case could be -1, 1, 0, sorry, and 1, but not 2. So the red one is just going to be these 3. And you might get 2 of these and you have to compare the 2 and say what the difference is. For example, this one includes 2 and 3, whereas they both include -1, 0, and 1. That's how you use those open dot, closed dot questions. Let's on to the next part. It's quite a good lesson, this one, not too taxing. Right, now this is equations with inequalities that are very similar to linear. Very similar to linear. It's the same kind of thing that we do. So x plus 4 equals 10. There's a linear equation. So we need to find out what x is. So subtract 4. So x equals 10, take away 4 is 6. Now an inequality looks like this. X plus 4. And we can have that. So we can have a symbol. And we can have any one of the 4 symbols there. And it won't make any difference at all. Yeah? So this one, we just subtract 4 to give x is that, and 4 away from that is 6. So x is greater than 6. It has to be, because if it were 6, then 6 plus 4 does equal 10, but we've got to have it bigger than 10. So that's how we do that. And we're just doing the opposite stuff all the time. It's exactly the same as linear equations. Yeah. So the only thing that you have to worry about this is where we have a when you divide or multiply by a minus. And I'll show you what happens with that. So if we have x over minus 2 is less than 3, and we need to find out what x is, what we would normally do is we would multiply by minus 2, yeah, to get it over there. So we'd have x, and 3 times minus 2 is minus 6. Now, because we have divided or multiplied by a minus, you flip the sign. You change the direction of the sign. That's all. So not the end of the world if you don't. You'll get half points, but remember, if you're going to multiply or divide by a minus number, then the sign changes direction. So we'll do a few of these. 2x minus 4, 18. So we're going to add 4 to get rid of that minus 4. Add 4 onto that is 22. And then divide by 2. So we're dividing by a plus number, so the sign remains the same. And that becomes 11. And some more. Well, we can't get enough of these, can we? Yeah, 6x minus 9 is less than 9. So we're going to add 9. So that leaves 6x. Add 9 cancels that out. That makes 18. And then divide by 6. So x, 18 divided by 6 is 3. Yeah. So 5 minus, oh no, minus, less than 2x less than 15. Now, x in the middle now. Now, what we need to do to find the value of x, or possible values of x, we need to have a single x in the middle. So we're going to divide everything by 2, and that will leave us an x in the middle. There's the signs, there's the signs. 15 divided by 2 is 7.5. 5 divided by 2 is 2.5. And so x is in between. So if this was on a number line, you'd have 2.5 and 7.5. And x is in the middle of those two. So 31, 3x plus 1, that, 49. Now, what I'm going to do with this one. Now, so we need to subtract 1, just as if we were doing with the linear equations. Ignore these bits on the end. We need to get rid of 1. Now, we get rid of 1 on all 3 parts of the equation. So that leaves 30 over there, 3x in the middle over there, and 48 over there. Now we need to divide everything by 3 to leave a single x in the middle. We got that, that, that. That divided by 3 is 10. That divided by 3 is 3/16 of 48. 3/16. So now, if you were to draw this on a number line, you'd have 10 there and 16 there, and this would be a closed dot. Yeah? So there is that represented on a number line, and then you could say all the possible values of x would be 11, 12, 13, 14, 15, and including 16. Good. So let's do 3x minus 2, that, 13. So what we're going to do here, this is x just on one side. So let's add 2 to leave us with 3x. Add 2 there, that gives us 15. And then divide by 3, x, that divide by 3 is 5. And 2x plus 7 equals x plus, oh, it doesn't equal, does it? Yeah, let's do this as a linear, right? As a linear with x on both sides. So what we do with a linear, we're trying to get rid of the x's on one side. So let's subtract an x from both sides, which will leave x plus 7 equals 11. Then take away 7, which will leave x equals 4. So there's a linear equation, and we possibly can do the same if we got an example in a minute. So let's go back to 9 minus 2x is greater than 15. Now let's take away 9, see where we go. Leave the minus sign there, it's important. Take away 9 from that is 6. Now we've got to divide by minus 2. Now remember, when we divide by a minus 2, the sign flips. So this will be x that way round, and 6 divided by minus 2 comes out as minus 3. So you've got the kerfuffle with different numbers there, minus numbers. Let's have a look, see where we're going next. Just more of the same, really. It's just practice this. And if you can't find enough examples of this, just take a linear equation and put one of these symbols in the middle. So minus 3 leaves 4x. Take 3 away from there is 24. Divide by 4x. 24 divided by 4 is 6. 4x is greater than or equal to 18 minus 2x. Now we've got x's on both sides. So what we're going to do, let's add 2x. Yeah, then it get rid of the minus sign. So we'll add 2x to both sides. So that becomes 6x and 18. And then divide by 6. This x is that way. 6 is into that, go 3. 6 minus 4x, that, 18 again. All right. So let's take away 6, which leaves minus 4x. 6 away from that is 12. Now I've got to divide by minus 4, so the sign is going to flip. X, flip the sign, and we've got 12 divided by minus 4, which is minus 3. Go down to another one. Last one, this one, on this lesson, yeah. So, well, this looks a bit complicated. Minus 8, there. 5x plus 2, 20. 2. So we've got all this stuff in the middle that we need to get rid of. So let's get rid of a 2 first. Now, minus 8 minus 2 comes out as minus 10. Still got 5x in the middle. And then that, and 20, 20, yeah? Now, divide by 5, everything. So that becomes minus 2. That becomes x. And that becomes 4. And so the possible values for x. So let's do this. We've got a closed dot that side above the minus 2. And we've got a closed dot that side above a 4. So x is everything in between. So if we have a number line, whether I can get all these in, minus 2, minus 1, 0, 1, 2, 3, 4. Possible values for x are all of these because they include the minus 2 and 4. So minus 2, minus 1, 0, 1, 2, 3, and 4. Okay, that is the end of that lesson.